Okay, so lesson 6, graphing the primary trig functions. So this becomes the essential task of Math 30-1 and Math 30-2, is just in graphing all of these things. And now we're going to deal with graphing trig functions. To start off with, we need some new vocabulary around functions, because the trig function is what we call periodic. That is that it repeats over time. Lots of things do that in real life: sun, days, temperature, tides, all sorts of things. But we need to develop a new vocabulary around it. So period and amplitude. The amplitude is the distance above and below the midline that a graph goes. So this is a measure of 10. This down here is also a measure of 10. So it'll always go above and below the midline by a common amount, and we call that the amplitude. So the amplitude for this graph is 10. The period is the length of time, or whatever your x or inputs axis is, that it takes for the graph to repeat itself. So that is to go from midline going up to the next time we hit the midline going up, from peak to peak, from trough to trough, midline going down to midline going down. Any of those will work. Usually peak to peak and trough to trough are the best. People will make sometimes the mistake of going from midline to midline, but here I've gone from midline going up to midline going down. So the graph hasn't actually gone through a complete period. So on this particular graph, if we look at going from the peak at 2 to the peak at 10, that's a span of 8 units. So in this case, my period is 8. It repeats itself every 8 units. Now, this next graph, my midline isn't as clear. Here my midline is the x-axis. So I have to find my midline first. If I look at 6 and negative 2, that's a span of 8. So the midline should be 4 above and 4 below that. That would make that 2. So there's my midline. So if my midline is 2 and my peak is at 6, that means that my amplitude is 4. And then again, if I look at my period, on this one, I'm going to go trough to trough. Why? Because my first trough is right at the x-axis. So that's an easy one to look at, or the y-axis, I should say. So my next peak happens 6 units away at 6. So in this case, my period, I'll color coordinate here, is 6. For this one, you've got to be a little careful. And this isn't what our normal graphs look like with trig. That would not actually be a function because of all these vertical lines here. Remember, the vertical line test is the essential test of functionhood, and that wouldn't work. But we can still measure the amplitude and the period of this thing. So the amplitude, the midline is at 4, and it goes 2 above to 6 and 2 below to 2. So my amplitude in this case equals 2. 2 above 4, 2 below 4. My period would be the length of time taken to completely do a cycle. So I think about this one, I'm going to measure from my top right corner of this graph. The next time it hits its top right corner would be at 10, and then 20. And then 30. So I can see that the period in this case is 10. You could say, what if I'd chosen bottom left corner? Well, this would be 5. Next bottom left is going to be 15. Next bottom left is going to be 25. Oh, wait, it's still 10 for the period. So what we're going to do now is we're going to see how this works with our actual trig functions. So sine x. Sine, we think about our unit circle here, and the sine is the y values. This would be the point 1, 0. Not so much a 1, but that's okay. And so sine starts at 0. Then it's 0.5. Again, if I was just typing these into my calculator, I could get the answers out of them. I'll confirm that this is true, just to show you that I'm not making these things up. So I'll make sure I'm in degrees here. And then go sine of 60 So that's that 0.866, or as I've abbreviated, 0.87. So again, if you want to check the rest of these on your calculator, do that. In fact, let's pause for a second here. Well, not yet, because I have to give you directions first, but I want you to pause the video, write in all the values, and then unpause it, and I will have all the values written in 5, 4, 3, 2, 1. All right, so hopefully you took that time to actually write the values in, as you can see that I have, and you should see something very similar. If not, check to make sure your calculator's in degree mode and all that good stuff. So now I'm going to plot this thing. So it's 0 here, and then each of these blanks is 30, right, because 3 of them is 90. So this is going to be 0.5, this is going to be 0.8, so that's about 0.87 right there. That's 1. 0.87, 0.5, 0, negative 0.5, negative 0.87, negative 1, negative 0.87, negative 5, 0. And that looks like a pretty nice little thing right there. There's my graph. Now, if we were to try this with our calculator, I could go y equals, oh, look at all that garbage I've got in there still. Okay, get rid of all that stuff. But y equals sine of x. And then I'm going to change my window settings just the ones that they are using down here. So from negative 360 to 540, going by 30. So window negative 360, positive 540, x scale of 30, just so those are reasonable numbers for me to look at. Y scale, we'll go from just negative 1.5 to positive 1.5. And Y scale, let's go by 0.2. We'll just use the same scale on this graph. So there's my curve. And what we can see is that not only does the part that I drew make sense, that would have been kind of right around here, but the graph continues to go on forever and ever and ever. Something like that. I haven't drawn that all that accurately, but you can see the idea. So it goes on forever. So what we say is that this is a partial graph because the sine thing goes on forever. So domain. There are no limitations on my domain, so it's just x is an element of the reals. My amplitude is 1. It goes 1 above and 1 below. If we look back up here, 1 above, 1 below. And then my period, the time taken from peak at 90 to next peak at 450, that's 360. Or I could say midline going up to midline going up. Well, that's 360. So it seems clear that the period here is 360. My range is from negative 1 to 1, including those values. It does actually touch those values. My x-intercepts are at 0, and then 180, and then 360, and that would be an infinite list. And my y-intercept, of which there is exactly 1, or else it's not a function, happens at the point 0, 0. So, if we did it in radian mode, we'd put the thing in radian mode. And let's pull my calculator up. This is one of my favorite tricks. Watch what happens here if I put it in radian mode. Mode, radian, second quit, graph. The whole thing looks like just gibberish. And that's because it's going up and down so fast that the graph can't capture what's actually going. But this is the best button in the whole calculator right here. Zoom, Trig. Here's what's genius about it. It doesn't even need you to tell it what mode it's in. It just checks that on its own, figures out what mode you should be in, and then sets that up. So the actual calculator window we'd want would be from 0 to 2 pi, approximately, maybe we'd want to go from negative 2 pi to 2 pi, or negative pi to 3 pi, or whatever it is that we want to do. This should do the trick, but even better is zoom trig. All right, that's the end of that lesson. Try the assignment, make sure it all makes sense, come back and talk to me.